Good morning, everyone. Today, what I want to try to do is distinguish the difference between what distance is and what displacement is. What we do know is that distance is the length of a path between 2 points. So, whenever you're giving direction to somebody and you're adding up all these different ways to get from one point to another, we are adding up what we call vectors, which gives us a total distance. Okay, it's the amount in meters, miles, feet, centimeters, whatever it is you're measuring. Okay, from one point to another. Displacement is the direction from point A to point B, but in a straight line. Many times when we get to a destination, we tend not to travel in a straight line. Think about when you go to the beach in a car. All right, you're going on certain roads. You're taking lefts, you're taking rights, you're going over bridges, up hills, down hills. But you're never traveling in a straight line. So we tend to calculate the distance based on the path that we take, when in reality, the displacement between where you start from and where you finish can be measured in a straight line. So if you look at the diagram down the bottom left, you see the person on the bike traveling through the mountains, okay, in a curved line, going up to the factory for a total of 200 meters. But if we were to calculate the displacement from the house to the factory in a straight line, we would find that it would only be approximately 120 meters. But yet, we cannot get from the house to the factory in a straight line because of the obstacles that are in the way. So what we're going to do in a little bit is we're going to show you how to calculate displacement and also calculate distance. Here is just a section of a map from Manhattan. If you look at the yellow line, in order to get to point A to point B, which is here's where I would start, and here's where I would finish, I would have to travel 8.2 kilometers to the nearest bridge, take a left, go over the bridge 1.8 kilometers, and then travel down another road, another 4.5 kilometers. Obviously, the yellow line much longer than the green arrow. So the yellow line represents the distance that we traveled, and we could add up the three vectors, 8.2 plus 1.8 plus 4.5. That would be our total distance that we traveled. Yet the displacement from the starting point to where we finished is much less, only 2.7 kilometers. Displacement is always going to be less than the distance traveled. And that's a key point. So again, displacement will always be less than the distance traveled. There's an old saying, the shortest distance between 2 points is a straight line. That is referring to the actual displacement. So what if we combine vectors, okay? Which is what we normally do. If I walk down one street, I take a right, go down another street, then take a left and go down another street. Each street represents a vector. So here, when we look at this diagram here of the girl walking, she went 1 meter one way, 2 meters, another 3 meters, then changed direction, 3 meters, went another 3 meters. So we could add up these vectors and see that she traveled a total of 12 meters, okay, from her starting point to her finishing point. But the actual displacement from start to finish was only 3. Maybe she couldn't get here. Maybe there was some sort of obstacle blocking the way. All right, so what we do is we use something called vector addition. Okay. Now, to calculate displacement, yes, we are going to use a mathematical formula, something we're not used to seeing in science. You say, oh, well, it's only used in math. Well, here's why we use it. we're going to use the Pythagorean theorem to calculate that displacement. Remember, displacement is that distance in a straight line from your starting point to your finishing point. So if you recall from math, you may have seen the formula a squared plus b squared equals c squared. That's Pythagorean's theorem. Well, we're going to use this formula to calculate our own displacement. All right, so what I want to do over the next couple of slides is show you how we do use it. If John travels a total of 6 miles north, then travels a total distance of 4 miles east, what is his displacement using Pythagorean's theorem? All right, so the first thing we do is we kind of plug in the 6 and the 4. Those are his total distances. So here, and it doesn't matter whether I put it the 6 here, or vice versa. All right. Because the ultimate goal is to calculate displacement, okay, which is this unidentified arrow at this point. So what do I got to do with those distances of 6 miles and 4 miles? Well, I got to square them. Remember, the formula is a squared plus b squared. Now, c squared in our case is going to be the square root of the total of a squared plus b squared, okay? Once you get to this point here and plug in the information, let the calculator do the work for you. All right, I don't expect you to know square roots in your head. All right, just use the function on your calculator. So we know that 6 squared is 36, and we know that 4 squared is 16. Okay, 6 times 6, 4 times 4. So step 2, we solve for that. All right, 36 plus 16 is 52. But in order to get the displacement, remember, we got to take the square root of that total. Okay, and 36 plus 16 is 52. So the square root of 52 is going to be our displacement. Now, before I calculate what the displacement is, you might be asked, well, what was the total distance John traveled? Well, what did he travel? He traveled 6 miles plus 4 miles. So he's traveled a total of 10 miles. Okay, to get from where he started to where he finished. But what is the actual displacement from where he started to where he finished? And that's where we use this formula. So the square root of 52 is 7.21 miles. So our C here, our displacement, is 7.21 miles. Remember, displacement is always less than the actual distance. All right, let's take a look at a couple of other examples to follow along before we do some practice on our own. All right, and what you'll notice too is I like to draw out my diagrams. I'm a visual learner, so when I'm reading any type of word problem, if I can do the work on the side and map it out, it's definitely going to help me ensure my accuracy of getting the right answer. So here we go. Alex goes cruising on his dirt bike. He rides 7 miles north and then turns and rides 8 miles east. What was the distance he traveled? And then what was his displacement? Remember, the distance we can calculate by adding up the vectors in the problem. 7 miles, 8 miles. So Alex here rode his dirt bike 15 miles. Okay, so now we want to calculate the displacement. How far was he actually from where he started to where he finished? Okay, so I'm going to label my A and my B. Okay, and again, I'm just going to put 7 for my A because that was the first number I saw here, and then my 8 as my B. All right, so now the goal is to figure out what the red line is, what his displacement was from here to here. All right, so we know that he, like I said earlier, we know that he traveled 15 miles. We just added up the two vectors, 7 plus 8. So let's calculate the displacement here now. All right, so again, what do we do with these numbers of 7 and 8? Well, we got to square them up. Go back to the previous slide with the formula. A squared plus B squared equals the square root of A squared plus B squared. All right, so what is 7 squared? What is 8 squared? 7 times 7 is 49. 8 times 8 is 64. That's the elementary part. All right, so now we just add up the total. 49 plus 64 is 113. use your phone, use your calculator, square it up, all right, to get our displacement value. And when I do that, our displacement is 10.6 miles. So even though Alex traveled a total of 15 miles, he was only 10.6 miles away from where he started from. Okay? And again, displacement will always calculate out to be less than the actual distance. Okay? Here's another problem. Andy the ant crawls 6 feet up the hill to find some bread, then turns right and walks down the hill 4 more feet to bring it to his family. What is the distance Andy the ant traveled, and what was Andy's displacement? Okay, now again, the units of measurements that we're using here are feet, not miles. Okay, but that's irrelevant right now. Okay, what we do want to figure out is how far did the ant travel? All right, and I'm sure by now you can figure out that he traveled 10 feet, 6 feet plus 4. And then now we got to calculate his displacement using the Pythagorean theorem. All right, so the first thing I'm going to do is label my A and my B vector, okay, with the 6 and the 4. And then, all right, we've already identified how far the ant traveled, which was a total of 10 feet. So I'm guessing that the displacement is going to be less than 10 feet. So let's plug it into our formula. We square up the 6, we square up the 4. 6 squared plus 4 squared, that's going to give us 36 plus 16. So now we just square up that total of 52. The square root of 52, 7.21 feet. Okay, so the ant was actually only 7.21 feet from his starting point to where he finished. So far, so good. All right, again, notice everything that I do. I label my vectors, I plug those numbers into the formula, I square them up, and then I get the square root. And the square root is going to give me my displacement. All right, next example. Mr. Saab rents a private jet on his teacher's salary during distance learning and flies southbound 400 miles and then heads westward 500 more miles until he reaches his private island in the Caribbean. What was the distance he traveled? And then calculate his displacement. Now notice my diagram. I represented with arrows. So the first vector that I saw was traveled southbound 400 miles. So I drew an arrow going south 400. And then I turned westward for another 500 miles. And I just labeled that B. So my goal here is to actually calculate the displacement from the time I left to my destination at my island. Okay. So the total distance that I traveled, forgot to put Mr. Saab, not Alex. So the total distance I traveled was 900 miles, 500 plus 400. But let's calculate the displacement from or to the island. So 400 squared plus 500 squared. Dealing with big numbers doesn't mean you can't do it. We're just going to be dealing with bigger numbers. So we got 160,000, which is the 400 squared, 400 times 400, plus 250,000, which is my 500 squared. So when I add those two up, that's going to give me 410,000 miles. But I want the square root. The square root is going to actually give me my displacement from where I took off to where I landed at my own private island on my teacher's salary. I wish. So the displacement, even though my plane flew 900 miles, I was actually only 640.31 miles from where I needed to go. Now, what could be the reason? Okay, well, maybe I had to travel a little bit longer because of the weather patterns up in the sky, or the wind patterns. Just whatever exists up there in the air that a pilot might need to go an extra distance, all right, to avoid any possible complications. All right, so let's move on to my last problem. Now remember that displacement is the distance from start to finish. So what if my starting point and my finishing point are in the same place? How do we calculate that? Well, here in this example, think of a track. You're a track athlete. Here I am on the starting line. I'm running around the track to the finish line. Well, my starting point and my finishing point are in the same spot. Now, some of you might already be thinking about what the possible answer is. Okay. Even though I traveled a certain distance going around this track, doesn't matter how many times I go. All right. My starting point and my finishing point are in the same place. So let's take a look at example 4. John runs the track for Tillman High School, and his specialty is the 3-mile run. Every 4 laps is equal to 1 mile. The starting line is the same as the finishing line. What distance did John run? How many laps did John run? And what was John's displacement? Now, you might already be thinking, I don't think I need Pythagorean's theorem to calculate the displacement here. Well, if you're thinking that, you are right. But let's take a look at the problem. We have 3 things we have to answer. What distance did John run? How many laps did John run? And what was John's displacement? All right, so let's take a look at what distance did he run. All right, now in the information here, all right, we know that he ran 3 miles. Every 4 laps is equal to 1 mile. So what distance did he run? Well, I said it, 3 miles. Okay, so he ran 3 miles. How many laps did John run? Well, if every 4 laps is 1 mile and he ran 3 miles, 4 times 3 give me 12 laps. I could go around 1, 2, 3, 4 is 1 mile. 1, 2, 3, 4 is 2 miles, which 8 laps, and then 1, 2, 3, 4 more laps to finish will give me a total of 12 laps, my 3 miles. Okay, now the big question, what was John's displacement? Well, he ran 3 miles in a circle, but he started and finished at the same spot. What is his displacement? Displacement would be 0 because the starting point and the finishing point were at the same spot. Here, the displacement equals 0. Now, what we'll do shortly is try a few of these problems on our own. But if you have any questions, go back into this video. Look at those examples that we just did. Look at how I set them up with a diagram, labeling my A and my B vector, using a different color, or even use a dotted line to recognize your displacement line. Square up those A and the B's that you got so you get your sum or your total. Then you square root it. That square root of that total is going to be your displacement. And finally, as we exit out, your displacement is always less than the distance. Take care. We'll see you soon.